Howdy and welcome back. So the final video today is going to look into clause 3 and runtime errors. And I'll continue, I guess, a little bit from where we left off in the previous video with this silly storage unit example to maybe hopefully modify this or motivate this. So, okay, what is the third clause? It is you will not return memory that you did not borrow. Let's say you have your note card and you go visit the person who is running the storage unit manager and you ask for a storage unit to store, I don't know, something, and they say 8. And let's say you inadvertently write down 7 and you go use it and you come back or whatever and you go, hey, I'm done with 7. And they go, we never allocated number 7, and there'll be some confusion there. And if this was in your program, a runtime error would occur. If this happened in real life, there's going to be some accounting they'll have to obviously look into this. Second kind of thing that can happen here with dynamically allocated objects, which is in your contract and you must kind of avoid here, is you will not return twice the memory that you borrowed once. So this could be like you write down storage unit number 8, you go give it back, you go tell the storage unit manager, hey, I no longer need unit number 8. And then let's say you forgot that you returned that. So day later, you go back and you go, hey, I'm done with storage unit number 8. I don't need it anymore. And they're going to look at their, what they've rented out and go, hey, that was never allocated to anyone. There'll be some confusion there. And in the case of your program, attempting to return something twice is going to throw a runtime error. So let's look at this with a C++ specific example. Hopefully the storage unit example helped illustrate or motivate this a little bit. But let's say we go request from the free store manager a dynamically allocated integer, and we store the address to that object in P, and we set up this relationship. P is pointing to an object on the free store that is initialized with the value of 7. Let's now say we go do something and it's time to return that object. So we call delete on it, on the address to that object, and its memory is 0, or its memory is, we can reclaim it for use with something else. Now let's say that you do something else and you forget that you returned that memory and you attempt to do so again. This second call of delete on that address is going to result in a runtime error. Specifically, the runtime error that you will observe is going to be something like follows. malloc, error for some object, pointer being freed was not allocated. And this will actually terminate the execution of your program. So it's something to consider. And again, this is a kind of almost trivial example in the point we're dealing with one pointer. Now think about the instance where in your program, you could have multiple pointers to the same object. And again, this is where this kind of accounting with the design of your application is going to become so critical. So let's say that P is a pointer to this object on the free store, storing the integer value of 7. We go ahead, we do something, we go somewhere else, maybe create a pointer to that object, and we end up with 2 pointers pointing to the same object, OP and P. So at this point, we can access this dynamically allocated object through either of those pointers. And let's say we continue to go on our merry way and then decide that, okay, hey, I don't need this dynamically allocated object anymore. I'm going to return it. And I'm going to do so by calling delete on the address stored in OP. So at that point, memory for that object storing 7 has been deallocated. And just to be, complete, you go ahead and you say, okay, OP is not pointing to that anymore. So it takes care of the dangling pointer. Had we not done this and deallocated the memory, OP would continue to point to that address, but we'll go ahead and destroy that relationship by putting 0 or the null pointer into OP so that it is no longer pointing to that object whose memory has been reclaimed. Okay, but P was also pointing to that object, and maybe somewhere else in our program, wherever P is declared, we don't realize that we had deallocated the memory associated with the object pointed to by P, and we attempt to do so. So we call delete on the address stored in P, which is the address of that once existing integer object who once stored 7 for us. And at this point, we'll observe a runtime error, And the message again is clearly communicating that the value we're attempting to free was not allocated for. So I guess just to recap, scroll back up here to the top. We've gone through this implicit contract that we have essentially entered with the free store manager when requesting dynamic memory. We went over 3 clauses, the first one being that we will eventually return the memory that we borrow, and if we fail to do this, a memory leak can ensue. Furthermore, the second clause of this contract is that we will immediately stop using the memory that we've returned, and we said that the result of violating this clause would be a dangling pointer. We talked about how it's always best practice to go ahead and after freeing, so after, if we have this relationship, it's always good after we've deallocated the memory with this object that we update the pointer to no longer point to it. And then finally, the third clause was we will not return memory that we did not borrow, and we will not return anything twice. We've gone through and we've illustrated how if we do violate this clause, a runtime error will result.